I would like to move in that case now to our next presentation, which actually is going to give us a bit more information on that design of the ships. Exactly the issue what we started just now when we got a retrofitting. That applies to our new ships as well. We've got a need for standardization. And I would like to invite Mr. Krzysztof Czerski from Seatech Engineering to give us a presentation on low emission propulsion system and a few examples on the ships what Seatech Engineering is dealing with right now. So Krzysztof, if you are ready, please, stage is yours.
Yes, good morning. Thank you very much. I hope that you can hear me. Then I will try to share my presentation. All right. Could you confirm if you can see my presentation? I will
yes, we can see your presentation, yeah.
Okay, perfect. So, thank you very much. Good morning once more. Thank you very much, Motus Foundation. Thank you very much, your partners, Port Gdynia, Polish Register of Shipping and Shoreline, for invitation, for your kind invitation for Seatech Engineering. I would like to present you a little bit what we are doing right now with our new, let's say, developed ships. So it's a pity that again we are meeting with through the screens, not in the real life. To be honest, I'm usually prefer the face-to-face meeting instead of online. But however, I hope that soon the pandemic will be over, and then next session we will have in the nice place when we will have the possibilities to talk face-to-face. So my name is Krzysztof Czerski, and I have a privilege to work with Seatech Engineering. Seatech Engineering is a ship design company located in Gdańsk, but with small subsidiary offices in Szczecin, close to the German border, and also in Rumia, which is 20 kilometers north from Gdynia. In Rumia, there is energy and LNG and energy department, which I'm leading. So best regards from the sunny Rumia. Now, right now, it's a beautiful sun shining outside the window. So the first slide, this is, let's say, the content of my presentation. And first slide, I would like to start with the short information about the Seatech. We are an engineering company established in 2003 as a part of the French group Piliou. But however, from 2018, we are fully independent because we had the agreement with Piliou that our management of Seatech buy out the shares. So we are totally independent right now company, but however, still very close cooperating with Piliou shipyard or Piliou shipyard group, because there are a couple of the shipyards around the world. And as a Seatech, we are not only the ship design company, we have also in our, let's say, portfolio, some services for the brokering. So we together with the Piliou, we participated in the purchasing or the building of about 30 partly outfitted hulls in Poland, mainly for the French market, but also for the others. So we are doing the ship design, we are doing the retrofit design, especially the scrubbers and the ballast water treatment systems. And also we are focusing a lot on the LNG bunkering solutions. So I'm really very happy what I heard from Mr. Krzysztof from Port Gdynia authorities. So we really also believe that sooner or later we will have the LNG bunkering vessels here in Polish harbors. So I believe that this vessel will be designed by the Polish design office, maybe by us, and also will be built somewhere in our shipyards. So we also, Seatech is also a representative of the Dassault system software called 3D Experience. So that's not only engineering company, it's quite very wide scope. So back into the topic of my presentation, I would like to present you 3 different solutions for the low emission propulsion system based on our latest designs. First is the conventional fuel, because with the low emission propulsion system, it doesn't mean that we should concentrate only for the low emission or alternative fuels. We can also propose the low emission propulsion system for the conventional fueled vessel, but only what is the important, this is the very clever optimization of the existing propulsion system, means main engine, which is installed on board. Second proposal, which I would like to present you, is our LNG fueled ferry, which will be able to convert to the future to the other alternative fuels. But however, this ferry is not only running on the LNG, but also on the solar power, and also it is equipped with the connection to the shore link. So, but however, I will explain later on. And the last, the future, the zero emission future. This is the crew transfer vessel for the wind farm services, and we developed this vessel as a run on the hydrogen. I would like to concentrate on the three fuels here: the conventional, let's say low sulfur MDO or marine gas oil, LNG, and also hydrogen. I don't want to touch to the other fuels, because I suppose that the other alternative fuels like methanol and ammoniac, they are quite good for the deep sea vessels. But also I don't want to grab some part of the presentation to my great colleague Piotr Kabaciński, who will have the presentation in the end of today's session. Yes, let's back to the, let's say, to our time when we were very young and we were in the study in university, and the professors teach us how to design the propulsion system. Of course, in the conventional way, we had the power curve for the vessel, and we have the service speed, which is given by the owner. And then from the service speed, we will choose the engine. Usually we keep this 50% sea margin for the rough sea, for the current, for the growing of the underwater part. And also we kept some safety margin, let's say, for the engine, because through the years the power is decreasing of the engine, and then we kept this 50% MCR. And also the producers of the engines optimize the engine to have the lowest specific oil consumption just for this contractual point, because this point we called contractual. And this curve is rising when the power is increasing, and also is rising when the power is decreasing, especially for the very low load scenario. For the 50% load, this fuel consumption is really quite very high. Again, this engine was optimized, the engines were optimized for this contractual point. And we call the system conventional. And we have now conventional system at sea, but what happens if, due to some different circumstances, the vessel should sail a little bit lower than assumed speed for in the contract? So what means that we have also the power needed the lower for this lower speed. That means that the consumption curve, which we have here, is giving us the much bigger value of the specific fuel consumptions. Of course, the vessel is generating less, the engine is generating less power, but the consumption sometime is even higher in this lower consumption. What to do? The best way will be to operate this engine in this point. But what to do with the surplus of energy? So this solution is called hybrid. So we can store this surplus of the energy in the battery. And in case of so much energy, the power management system is deciding to store the energy in the batteries. So we call this system hybrid, and this hybrid system is mainly helping us to shaving the peaks of the load of the engine. So thanks to this, we are receiving the more or less average main engine power, which is flat, and all those peaks are transferred when we are loading batteries, when we have so much power, or we are using the power from the battery if we have to add some power due to, I don't know, heavy wind or a rough sea or something like that. And this is this example, the conventional fuel system on the multi-purpose vessel designed by the Seatech. This is the more or less multi-purpose vessel, with the accommodation and the engine room forward, because it is creating the big space for the industrial cargo, the box-shaped cargo holds, and also the possibilities to install the long cargo on the deck. On the picture on the beginning of the presentation, there was a visualization of this vessel with the windmill propeller blades, which we suppose that the vessel will be very good for this, let's say, distribution of the wind blades from the main harbor or the producers to the local plants where we will have the installation of the wind farms. The vessel is 100 meters long, and the installed power is 3060 kW plus 400 kW hour installation in the batteries. This is quite small amount. This is something like a 10%, but it is giving us possibilities mainly to do this peak shaving. So when we have the batteries, this vessel is rather not, let's say, designed for the operation on the batteries only. The batteries will be used only for the peak shaving. The power distribution system is more or less looks like here. We have the DC grid here, and we have the generators, diesel generators, which are producing DC energy, direct current energy, and then from this bus bar, we are transmitting the power to the propulsion engines, also DC, and also a surplus of the engines we can transfer to the battery packs, which we have here. And in opposite, when the power of the engines is not enough, we can use the power from the batteries and to transfer to the bus bar, and to transfer to the electric motors. We have also connected to this DC grid. We have also boat thruster, which is connected. Then we have the frequency converter, transformer, and then we have the classic conventional distribution switchboard for 440 volts or 400 or 230 volts. Also we have the emergency switchboard, and we have all the feeders, and of course we have the shore link. But however, this vessel is quite low consumption. The vessel has the quite small demand for the power, is something like 350 kW. So I suppose that short connection can be here to the emergency switchboard or to the main, but however AC switchboard. And on the vessel, this system looks like that. We have the engines here, the diesel generators. We have the 3 engines. In this case, we are based on the Wärtsilä 6L20 engines. Then we have the switchboards, the DC and also AC, and we have the batteries, propulsion motors, and the propellers. Of course, here we should have the details like a thrust bearing, etc. But this is only for the presentation purposes, because otherwise the picture will be blocked by the small details, and it will be impossible to see those main components. And the second, let's say, proposal of the low emission propulsion system. This is the LNG fueled double-ended ferry, which we are designed for the new harbor in Poland, means the Elbląg harbor, because I suppose that sooner or later this channel through the Vistula Spit will be ready, and then the Elbląg will be open for the seagoing vessels, and we, let's say, take liberty to propose the LNG dual fuel, let's say the double-ended ferry running on the LNG, but also on the batteries, which can serve from the Elbląg to the city, to the 3 city harbors, means Gdynia, Gdańsk, and also to the Hel Peninsula. We suppose that Elbląg will be good place because the Elbląg is the shortest way on the express highway from the Warsaw. And it will be a really great place to board the passengers, and in the summer season to transport those passengers from Elbląg to Hel, because the distance on the seagoing on the sea road takes something like with the speed of the 24 knots, it takes something like a 2.5 hour. including some decreasing of the speed on the Vistula Lagoon. It will be more or less the same as we will go around the 3 City, Władysławowo, and all the harbors up to the Hel. So the 3 hours the driver can rest on board, and they can spend the time with the kids, playing on the kids play here, and also he can see the beautiful Baltic Sea. So I suppose it will be good alternative for the let's say road transport. Also, not only in the summer, we are thinking not only about the summer season, but also about the winter season, because the vessel can be, this ferry can be very good vessel to supply, for example, trucks from or the buses or the vans for the supplying the shops on the peninsula, restaurants on the peninsula, and they can be transferred by this ferry from Elbląg, and they can serve the goods on the peninsula, especially because on this ferry we have that something like 20 connections for the fast charging electric cars. So we can have this ferry like a hub for the charging the local trucks, which can serve which can transfer the goods in the peninsula without any emission. So, but however, this is the concept of the ferry. I would like to talk about the propulsion system. And here we have this ferry. We have the 2 separate engine rooms and 2 separate DC grids from the safety reasons. And because we have the 2 separate grids with the 2 separate tanks, we can avoid situation with the dual fuel engines, but of course they are very good, but we don't want to have the liquid fuel on board. We have only LNG, and after regasification, we are transferring this LNG to this aft engine room and also to this forward engine room when we have the gas generators, again with the DC grids, and this DC grid is transferring through this DC grid, we're transferring power to the main propulsion motors and also to the battery packs. And also what I forgot to mention, the vessel has the solar panels, which is something like 300 solar panels on the roof. So we have something like 80 kilowatts, which are available to charge the batteries from the solar power with the, let's say of course, in the daytime. We have also the shore connection. We can have the shore connection to the DC grid, but I suppose that because then we don't want to be, let's say, rely on the one harbor only. So we can rather connect to the shore connection to the AC grid. I'm really happy to hear what Mr. Koppelman presents about this solutions from the shore link. So it is really a good proposal for our vessel. And then we have the feeders mainly in the accommodation area. And here we have this vessel, and this system looks like that. We have the LNG tanks with the regasification system. We have the diesel engines, we have the switchboards, batteries, solar panels on the roof, and we have the propulsion pods, 4 pods, which has the possibilities to turn 360 degrees, so the vessel can have the excellent maneuverability for the crabbing, for the turning, and for the all operation in the tight harbors like Elbląg Harbor is. So when we are designing this vessel, also we are thinking about the future, because the hull probably will be okay after the 20-30 years. But what we still don't know what the future brings. I don't know if the Motus Foundations will invite me for the Innovation Days 2031 or 2035. So maybe we will have the more clear view about the future. But however, for time being, this vessel is designed that very easy we can replace the LNG tanks by the liquid hydrogen tanks, and the engines we can replace with the fuel cells. And then we are receiving the vessel, which is totally zero emission vessel running only on the hydrogen. And this preparation for the hydrogen on the ferry is giving me the possibilities to also to present you our newest, let's say, hydrogen operated vessel, which is the wind farm crew transfer vessel, which we designed especially for our Polish offshore wind farms, which are in plans. I suppose that sooner or later somebody will start to do the not only talk but also to start to do the real job on this wind farms. And this is the hydrogen vessel which can transfer the servicemen from the harbors to the windmills to do the service, to do the maintenance and everything. The vessel is quite small, but however quite powerful. It is 1,250 kW plus 280 kW on the batteries. The vessel has 4 crew members with the 4 berths and also 12 seats for the passengers. Eventually can be transferred to the 2 crew members with the 2 berths and also 24 seats for the passengers. The vessel is catamaran, and in each catamaran we have this DC grid with the fuel cells. When that hydrogen is transferring from the tank which is installed on the open deck, which is right here, and the bunkering of the vessel is done by the replacing of this container. Additionally, on this top of the container, we have excellent space for the small solar panels. So even we can have the surplus from the solar on this vessel as well. So we have the DC grid, again, batteries, propulsion motor. It can be jet or it can be conventional propulsion. Then we have the frequency converter to the DC. We have the transformer to the DC grid. Because on the small boats, usually all equipment is running on the low voltage, 24 volts, or radio navigation equipment, some small pumps, because everything is small on this vessel. And then eventually we can have the frequency converter and the small DC AC grid for the short connection and also for the small feeders in the accommodation area for the kitchen or for the charging the mobile phones, computers, etc. So, and again, how it looks on the real vessel, we have the H2 tank. We base for the time being on the compressed hydrogen technology, but however, I'm rather supporting the idea of the liquid hydrogen with the low temperature, minus 250, because let's say, my background is from the LNG department, so I'm always saying that whatever we can learn on the LNG, we can use this cryogenical knowledge on the hydrogen, on the liquid hydrogen. So I suppose that it can be sooner or later replaced by the liquid hydrogen with the small cold box for the regasification of this liquid hydrogen. But for the time being, we have this compressed hydrogen, and we have the hydrogen lines which are supplying the fuel cells. And then we have the switchboards, batteries, and the propulsors, which can be jets or the fixed or the fixed propellers with the conventional rudders. Yes, and small summary in the comparison, when we can say that the conventional diesel mechanical propulsion is something like a 100% of the emission of the CO2, because I'm taking care about the emission of the CO2, because we have, of course, the emission of the SOx, but however, now due to the new IMO rules, we have 0.5 level globally and 0.1 here in Baltic Sea and the coastline of the US. But then we have NOx, which is, let's say, limited by the tier 3, which is now is quite low, and the all vessels has the SCR, selective cathodic reactor. So let's have the only CO2 emissions. So conventional vessel will have the 100% of the emission. Then for this conventional fuel, but when we will use the low sulfur fuel, forget about the scrubbers, because the scrubbers are not killing the emissions. They are only transferring the emissions from the air to the sea or to some chemicals which we should have export from world. But however, compared with this low sulfur fuel, we have something about 15% of the reduction. But of course, this is everything depends on the operation profile of the vessel. And then we have our Elbląg ferry with this hybrid LNG propulsion system plus solar plus shore power. Then we are assuming that the operation in the harbors in Elbląg, Tri-City, or in Hell can be done on the batteries only. The transfer through the Elbląg River on the also Vistula Lagoon and Vistula Channel will be done on the batteries, and we will use only the engines on the open sea. And then we suppose that we can run something like a 50% of the time on the batteries, 50% of the time so on the LNG. So in taking into account that the CO2 emission on the LNG propelled vessel is smaller than compared with the conventional fuel, we can say that we can have some 60% reduction of the emissions. And of course, future, when we can base in our crew transfer vessel on the green hydrogen, then we should have almost zero emission from this vessel. So thank you very much. In case of any questions, of course, I will be happy to answer on using this channel on the YouTube. So once more, thank you very much, and have a great rest of the webinar.
Thank you, Mr. Czerski, for the comprehensive presentation on the Seatech's projects and plans, what you are trying to achieve now. It's very interesting to see